at number 1. So number 1 is asking us to find the limit. And before finding the limit, we should go ahead and plug in what?
2.
The 2. And when you do, you are going to get 0 over 0. And what was the phrase that we used? Do more. And typically do more means factor out. So when I factor, I'm going to get limit as x approaches a 2. Top is difference of 2 squares. The bottom is as is. Does something eliminate? As long as something eliminates, the remaining, all you have to do is plug it in. Plug this 2 in, into this x. We get 2 plus a 2. The limit is going to reach the 4. Okay? Are we now ready for number 5? When something is telling us what value of k, so that it is continuous. When something is continuous, it has to be not an open circle, right? It's got to be closed. What that means is my left and the right must reach the same number, because if it reaches the same number, it's going to close the circle. So I have, let's plug in the 4 on the first one. 2 times a k times a 4. And if you want to multiply out the 4 and 2, go for it. But I want to show all the steps. Plus a 3 is equal to, we have kx squared, so k 4 squared. So then let's do our step-by-step process. It's going to give us 16k. And when you solve for k, I believe that's going to give us 8k is equal to 3. So our value of k is going to be 3 over 8. So if the k value is 3 over 8, the function will be continuous, meaning the circle will be shaded. All right. Next one, number 16. Okay, on number 16, we're finding the derivative. When two things are multiplied side by side, we are going to use product rule. So as a reminder that you should be looking over every day. Oh man, card number 2. Take it out if you haven't memorized it. If you have, that would be great. But here it is. So we have product rule. So let's go ahead and put them side by side, separated by our parentheses. Maybe right here. Okay, let's recall our rule. To find the derivative using product rule, do I derive the first one? Or do I derive the second one? Find the derivative of the first one. So 5 is our constant, or coefficient, so I'm going to leave that alone. The derivative of secant. When I derive the secant, I get secant tangent. Let's write that side by side. And then I get the second one we keep. What operation separated these? Addition. Which one separated or was separated by a minus sign? Quotient rule. Thank you. And I'm going to go down here a little bit since I don't have room. We keep the first one. And we take the derivative of the second one. And what is the derivative of my second one? Secant square root of x. Now, if you stop here, I'm perfectly fine with. If you wanted to put the tangents together and secants together, go for it. And let's see what that looks like. So if you give me the following, I'm okay with 5 times the secant x, tangent squared of x, plus 5 times, and how many secants do I have on the second component? 3 of them. So you can keep it as it is, combine if you want to, doesn't really matter for me. All right. Are we ready for number 21? Now, if you watch the question or the video on number 20, this was a derivative, so derivative is 4. Heads up on that. So because I want to compare 21 and 22 to this one, I'm going to write out f prime of x. All right. So now let's see what's happening. I'm going to compare what's happening on 20 to 21. What is different about the given on 20 to 21? The bottom is absolute value, and not only that, this one told you what the derivative is going to reach. Did the second one give you what it's going to reach? Nope, it didn't tell you equal to whatever. So all this is saying is the following. and I'm going to use my card. Let's compare this to what I have. H approaching 0, I see that. I see x plus h. I see my x, and I see my h. So here's the bottom line. When I am looking at this and it doesn't give you an equal to, it's simply saying this right here is f of x, as my formula says. And the question on this one is asking us, if we're finding a limit as it's approaching 0, it's saying, what is the slope? So write this down. At x equals 3 of absolute value of x. Because sometimes doing the problem is not a problem, but knowing what it's asking for, that might be a problem. So let's go ahead and make our graph. The absolute value of x is like a V graph. And it does something like this. So given the absolute value of x, when I get to my 3, what is the slope at this point? What is the slope at 3? What is our slope? Rise over run. Up 1 over 1. Up 1 over 1. Is my slope 1? So what is the slope? 1 when x equals 3 on the graph of x of f of x is equal to absolute value of x. So in this case, it's going to be 1. So if it doesn't tell you what the limit is approaching or limit is, then you have to actually figure out what is the graph, find that point, and what is my slope. So let's compare that to my 22. On my 22, where's my 22? There it is. Cody, the slope is 1 over 1 over here no matter what. Derivative is a slope function.
So on that type of graph, it's always 1 over 1.
It's always 1 over 1 if I give you an absolute value. All right, now let's move on to number 22. Any other question on this? Okay, I'm going to move on. So on number 22, let's compare to our function again. So we have, it's approaching 0. If you're not listening, you're going to go, why are we doing that? Okay? X plus h, x. So our function, the f of x, is represented by what according to my pattern here? Tangent of x. And it says the limit as h is approaching 0 means, what is our derivative? So what is the derivative of tangent that we used on number 16, I think? Secant square root of x. And this one did not say when x equals some number. And because it didn't really tell us any of that, it's simply the derivative. So if it says when x equals something, then you plug it in. If it doesn't, you just write it out with it in terms of x. All right, the next one I believe was 30-something, yes? 32? All right. Jameson, let's read number 32.
A particle moves along a straight line with equation of motion s equals t cubed plus t squared. Find the value of t at which the velocity is equal to 0.
Okay, let's go ahead and underline velocity. And let's go ahead and write on this one. If that's, I think I want to rewrite this as s of t is equal to t cubed. You don't have to, but I want to be a little more detailed. Plus t squared. Velocity is the derivative of that. So underneath it, write s prime of t. And if you want to write, well, that's also the velocity, write v of t if that makes you happy. The s prime is just simply saying from the original equation, I'm taking the derivative. So here I go. What is my derivative of t cubed? 3t squared. What's the derivative of t squared? Plus 2t. And it says where the velocity is equal to 0. Set that equal to 0. And I can factor both of them out as t, right? T can be factored out. So I have 3t plus 2. And then we want to go ahead and set them both equal to 0. So my t is equal to 0. 3t plus 2 is equal to 0. So I now have, that one's already done. What would I get if I saw for t on the next one? Negative 2/3. Now, one of the answer is good and one of the other one is not so good. Any idea which one is a valid answer? Is that the best answer?
Zero.
The 0. Because can time ever go backward? Time is never negative. Time can be 0.
You go back in time.
Can we go back in time? We don't want to.
Someone might be, not yet.
Not yet. Okay, there we go. I guess later on.
But then we'll be back to now, so it could be now.
So it'll be back to now. That's so confusing. All right, number 34. Gianta, let's read number 34, the last one, please.
The position function for a particular object is s equals negative 29/2t² plus 56t plus 33. Which statement is true?
Okay, so the fact that A and B is asking us asking about velocity, we have to find the prime of this one. So let's write on here S prime of t, which is V of t. Oh God, the pen, doing that again. What is the derivative of my first term right here?
Negative 29t.
Okay, negative 29t. What is the derivative of my second component? Plus 56. So constant is 0, so I'm not going to worry about. So just by the velocity, I want to look at the second one. The velocity at time t is equal to 0. I mean, at t is equal to 0 is 33. If I plug in 0, don't I get 56? All right. Part A says the velocity is constant. That means v is equal to just a number. Do I have v is equal to just a number? No, I don't. So really, in the end, even without finding the derivative, we should know that the initial position, no matter what, is a y-intercept of what? 33. Were there any other before I stop recording? Good?
So you didn't even have to.
You didn't really have to. But I guess you had to eliminate, but it wasn't part of it. Okay, I'm going to stop.